Hello and welcome to the channel. So we have got a Masco ME27 amplifier here, and this is a version 1. This is a 110 volt amplifier. It's from the States, and in this video we're just going to do an assessment of what this amp needs. It's in, and I've done a few of these amplifiers, and it's the same customer for the same as the Stromberg Carlson we did, and we did another Masco or 2 for him. I can't remember exactly how many. I think I've done 3 amps for him. So we're going to do this one. Now this one may have already had some work done to it, but we're going to mod this amp, and the other thing we're going to do is change this power transformer to a 240 volt. But unlike the previous Masco that we worked on, someone had already changed that transformer and put something a bit naff on there. We're not going to do that because we've got all the SAMs and all the information for this amp, and I'm going to get Michael at Modulus Amplification to spec this transformer out correctly for this amp. So we've got, and I've photocopied, I've just copied the SAMs, so we've got it here, because it was a brand new SAMs, I didn't want to just get it all messed up. So we've got the schematic here, and we've got all the information for the transformer there, so that's really good. So we've got plenty of info. We've got to do some measuring as well to get the right sizes and whatnot. So you can see we've got 5V4 rectifier, and I've got the tubes. It's been delivered with the tubes in a box. We've got 6L6Gs, a pair, 6SJ7 and a 6SC7, and another 6SC7 over here. We've got a hum balance adjustment, which is on the filaments obviously, and it's a little bit rusty. Got capacitor here, and that's been in there a long time, so probably works okay, but it's been there a long time. So let's turn this amplifier, well, let's just have a look at the front panel first, shall we? So you can see we've got mic 1, mic 2, phono and tone, and what we normally do with these is the phono input is useless, so what we do, we convert this to a master volume. The switch is on here, so that'll have to go because they're just noisy, so the tone control just won't have the switch on, and we'll probably put the switch on the back. Can't really see where we can put it on the front other than there, but that won't be very good because it'll drill straight through the logo. Where are the inputs? The inputs are on the back. Let's turn it round and look at the back. So here we've got the back, and you can see we need to replace the speaker sockets as well, because they are just a mess, and so is all of, ouch, and so sharp, and so is all of this. So not sure what's going on here at the minute. Someone's, as you can see, Billy Bodger's been at it, because that's atrocious to do that, but people do it. That's not good at all. And then you can see the sockets here. We've just got mic 1 phono. Mic 2 is just some kind of, I don't know what that socket is. Gooden, if you're watching, tell me what that is, because I've never seen that before as I can remember. And you can see someone's been doing a bit of bodgery here. There's some wires stuck in here, not sure what that's about. Now I was hoping to fire this amp up, but looking at that back panel, and yet when we look in here, you can see it has had some work done to it. Just looking at that, could we getting it level? We'll pop it in one of the cradles. Which reminds me, so someone sent me an email, and I looked at all my emails, and we've had a bit of a torrid week this week. Pink's really poorly, and it has been touch and go, and it's still 50-50, so she's really ill. So I've not really replied to a lot of my emails and things. I've been too busy with Pink and my dad and one or two other things, and obviously repairs. Anyway, I've digressed. Where was I? Yes, so I got this email anyway from this guy, and apparently he's building these cradles, and he's obviously probably watched some of the early videos where I didn't have a cradle, or one or two that I don't always use the cradles when we just had one. I have now got a couple more, which my neighbour made next door. So now I've got three. I've got the first one that John made me, which is actual fact is the most versatile of the three, because that one is, I can get really big chassis in that one, and I've got the other two just for medium chassis. In fact, we'll get one up and have a look, because we've got one spare and the big one is spare. So we just move the amp back a bit, and you can see I've got this is one of the cradles. So just put that in there like so, and push that together, and we'll nip that in there, and we'll nip that up like so. So there we go. So we've got him in the cradle. So anyway, this guy was kind of just offering to make these cradles. I think he's wanting to make them and sell them. So what I'll do, if you're watching now, as I say, I ain't a chance to answer your emails for various reasons. But what I'll do is, if you want to send me some pictures and things of the stuff you do, then we can push them on the channel, and then if there's any people out there that want one of these cradles making, I'll put you in touch with the guy. Anyway, back to the amplifier. So you can see we've got that in there. We can see pretty good. So we've got a bit of a domino capacitor going. Oh, a broken domino capacitor. Wonder where that was connected to. So you can see already there's issues with this. So it's had some capacitors swapped. Not sure. I have to get my head in here a bit and just have a bit of a look at what's been swapped and what hasn't been swapped. These coils on here, look, interesting. So yes, we had a lot of these capacitors swapped and things, and all that work looks okay. But then we've got all this mess here, this bodgery on the back there where the speakers are. And we've got a wire cut off here, and I'm guessing that's probably, there's two feeds for this, and there is on a lot of these Mascos, two primaries on the transformer, sorry. I'm thinking out loud and waffling. We've got ground. When they put the ground on there, oh dear, that really is poor. And if you can hear that bit of a noise there, that's Pink, who's a bit wheezy. And I'm not quite sure what's happening with the yeah, that's not. And that's the neutral negative on there, whatever you want to call it. Neutral on the return on there, and that's almost broken off, but that don't look very good. That's got to be addressed. And then we've got this, I presume that went there. Not sure what that's about either at the minute without looking at the schematic, or even if it's on the schematic. So we need to sort this speaker socket situation out as well. And then the secondaries and stuff come through here onto this thing here, and then we've got this coming through onto here, and then we've got there's various other things on there that's been snipped and chopped and whatever. More over the amp now, and I've got some of the tubes in, and we've got, we're looking at this way. Now we're obviously the opposite way round. So V1 is the tube in the corner there, and a V1 is a 6SC7. V2, which is this tube here nearest, is a 6SG7. V2 6SJ7, and then we've got 6SC7, and that's the phase inverter. That's that one there. Now this amp takes, according to this, if we look, so we've got 6L6 G's in this amp, you can see there, but what's come with this amp is 6L6 GC's, so they aren't the right tubes for this. So 6L6G is around about 19 watts, 19 to 21 watts, I forget now exactly, but these are the wrong tubes. We're going to put them in anyway, but obviously these max dissipation of 30 watts, rather large. So and this amp has got the original bias resistor in there by the look of it. Pop that in, and that's this here. You can see looks like a snake with the red circles on there, and I think it's 200 ohms if I remember. And I'll just check on the schematic, and it is 200 ohms, and that 10 microfarad cap there is the bypass cap. Now I've been looking at the capacitor situation on here as well, and if we look, hold this there, if we look, we've got 5V4G, and we're coming out of here, we've got 380 volts coming out of there, we've got 100 ohm resistor and 60 microfarad, 5k resistor and a 10 microfarad cap, which is then feeding the screens. So if we look in here, if I find something to point with, we'll use this screwdriver because it's not been switched on, and we are going to switch it on, and once we've switched it on I won't be pointing with a screwdriver. However, there's the 16 microfarad cap, because this is the socket for the 5V4. So there's the 16 microfarad cap. Now the 10 microfarad is in this can here, and if we look, you can see we've got this orange wire, and if we follow that orange wire along here, you can see it comes to the screens. That's pin 4. So that is in there, and then the other sections in there, which I think are 10 microfarad also. I'm just looking on here now, but whichever, I think they're 10 microfarad, but whatever they are, one is feeding the phase inverter here with the 47k resistors. You can see that's the phase inverter, and then the other one is feeding from here to this preamp tube, and then there's a wire here, you can just about see maybe, that's going to this preamp tube. So the can feeds the screens and the preamps, and this capacitor here is for the first node, and rather low, I think, so we'll be increasing those And I also don't like the idea of this. One is it's floating around, and two, it's been grounded on the side of the tube socket. And if we just drop back there, and if we zoom in, you can see, we'll just go back there. If we zoom in, you can see that the sockets are riveted on, and that's a no-no for if you're going to ground to them. So we've got the full B plus grounded on a rivet basically. So that is not the way to do that. So we're going to be looking at that as well. Now the other thing that I'm looking in here, so we've got a power fuse, but with no HT fuse. Don't see an HT fuse. No, there isn't. So we need an HT fuse. So that's another thing we need to do. The 5k resistor that we looked at there, if we go back in, and you can see, not spotted that 100 ohms yet, we'll have to look for that. But the 5k resistor there between the caps is this resistor here. There is a name for these, can't remember. But snake resistors, I call them. So green 5, black is 0, and then red indicates 5k. So the 100 ohm resistor has been removed at some point. So I expect these output tubes to be biased at around about 19 watts. So we've got all, we just need to put the 5V4 in. I said the 5V4 there, and there it is. And here's a nice RCA Coke bottle, and we'll stick him in there. So all the tubes are in now. The preamp tubes are the metal tubes as well, they're not glass. We've got a lot of brown wrapping paper here which we need to put back in this box. Right, so we're almost ready to power this up. I've got a speaker connected and I've got it on the 110 volt transformer, and I've got a 40 watt bulb ready just to power this up. But before we do that, I'm going to check some windings on it. Now the last one of these American amps we did, which was the Bell amp, we did find that one side of the transformer was kaput. And I'm hoping I don't find that on this one. So we need to find center tap, which is, I think, this wire here, if we look. And that goes over to, over to here. And our meter, we're going to try and prop up there, just in shot. And because we are zoomed in quite a bit. So we're looking for a resistance between center tap and pin 3, which is that one. And there we go. So we've got 98.2 ohms. So let's look at the other side, from center tap to pin 3 on the other side. Pin 3. 106. So that looks healthy. So the power transformer now 3.4, that looks okay. And we'll just make sure, see what we've got on the filament winding, which is, that's the 5 volt filament winding there. That pin 4 and 6. Oh no, they're the secondaries. Duh. Plank, they're not the filament. 4 and 6. So that looks right. That's the secondary. The filaments are 2 and and this one to an 8. They don't look too bad. I've had a bit of a change of plan, and I've removed the 5U4 and I've put just a solid state rectifier in while we're doing this. So let's switch on 40-watt bulb just to get us going. So we've got 161 volts on the secondary with that in. Obviously that the voltage will be quite a bit higher, but we're going to use that while we bring it up and just make sure that we've got no issues. So we've only got one socket on the back, and let's just plug into that, see what that gives us. Or we might have a bit of something. Right, so 166 volts, and if we go up and across, you can see there 166 volts. There we go. So we'll just increase the bulbs steadily and keep an eye on what's happening. So we've got 120 milliamps we draw in, and 50 milliamps of that will be the transformer. So we've got another 15 watts in there now. I'm just going to edge it up steadily. Now I've got 212, oh sorry, and it's dropping now as it's beginning to conduct. So yeah, we are getting something. 189 and dropping now. We're starting to conduct. 150 milliamps we draw, so about 100 milliamps, because obviously I'm deducting the transformer. There we go. Now I've got 75 watts of bulbs, and that's really going up now. So I've got a sound coming out of the speaker, but not much. I've got 219 volts, we're drawing 190 milliamps, so probably about 140 milliamps. Not a lot of gain coming out of there. So that's the mic 1. Mic 2 we can't plug into, and the other one is the phono. I can't hear anything coming out of that. Let me just pull back a little. You can just about see me twiddling the controls. So we'll take that out. That's shocking how that socket's mounted. Dear oh dear. Only a matter of time before that pulls out. Yeah, so mic 1 we can't use. Just go back there a little. Mic 1, but we've hardly got anything coming out of there. Very small signal, and we've got 290 volts going into it. So you do hear a bit of background hum as well, but that's not surprising with 16 microfarads of capacitance. 130 watts of bulb, 293 volts. We've got 100, not sure what we've got going into it. Got 175 on the wall, but of course that's the other side of the transformer. We're not actually measuring, but we can do that with this meter that we've got up here. We'll measure AC and just see what AC is coming in off that transformer. 8 volts? That can't be right. Oh sorry, 88 volts. These glasses again, just out of focus. 88.3 volts. So yeah. Now it says, again, if we go back to the schematic, it says on the 6L6s 350 on the plate there, you can see. me making that go out of focus with my finger. 350 volts there. 20 volts on the cathode. So let's have a look what's on the cathode of the output tubes, so we can measure that from here to ground. Oh, sorry, we're still on AC, aren't we? 18 volts, so we're almost up there with that, but remember we are on the solid state rectifier. Yeah, so we're not getting much output out of this, so there's serious issues with this amp. Let's just see what this... No, that's not doing anything. So we have got some output. So one of the metal tubes is warm, the other two are stone cold. One's lukewarm maybe. Ah, now that's just come up. Ah, so we've got a bit of a problem on that tube socket. Well, we've got a little bit more gain now, but this amp is flat out. Right, I think what we'll do is we'll go up on the bulbs a bit more. We'll stick a 150 watt bulb in with that 60. I don't want to take this off the bulbs unless I'm forced. I may have to take some readings, because obviously if we're changing the transformer on this, I need to find out how accurate these readings are compared to that schematic. So let's have a look AC now. Let's see what we've got across here. 108. What we got on the cathode. 24, so we're over with those, and that'll be the solid state rectifier. So we know it runs a bit sick, this signal problems. So let's shut it down. Just wait for that voltage to drain out, and it has done, and then I shall remove this. And this is the solid state rectifier that I use, and if ever you make these, make sure you put a seal over the top. When I make those for customers' amps, I always put a rubber seal super glued in, and it's a bit very dangerous to leave those exposed. Obviously that's only for test purposes, but I wouldn't give that to a customer. Right, so we've got the 5V4 in now. So when this amp's fully up to voltage, oh dear. Well, that's suddenly made the transformer. Wow. So that must be the filament on that filament winding then on that transformer that's doing that, because we didn't have that before, did we? Bet you can hear that on the camera. So a problem with that. Now that's only giving us 280, and it's 286 volts. It's jumping around a bit as well. We just go up. I don't like the sound of that. Yes. Right. And now we're drawing 450 milliamps. And if I take 50 milliamps off for the transformer, that step down transformer, we've still got that 400 milliamps there. That seems a lot to me. .42. Well, we're obviously not up to voltage. What we got now? 105. So drawing more current now. That obviously that voltage has dropped. That primary voltage coming in has dropped because we're drawing more current now. With that filament drawing more current on the transformer. So that's a noisy old thing, isn't it? So I'm going to put this 150 in now. So we've got 300 watts of current limiter. And that should probably give us about full voltage. Not quite. So this thing is drawing some current. That's now drawing 520 milliamps. That seems a lot to me. Let's see what cathode voltage let's see what's coming in first now. So we've got 113 volts coming in. So we're about there, 120 volts, somewhere between 110 and 120. We're about there. See what's on this cathode. 20.93. So bias is a little over according to the schematic, not much. Wow, that's drawing some current. 530 milliamps. 23 volts. So the bias is 3 volts over. Oh, our noise has disappeared. Ah. Our noise, oh, how rude. So let's just see what we've got on pin 3 there. 344. Yeah, that's about so. Must plate to cathode, plate to ground. They've got that. Obviously, we need plate to cathode. So that's a little down, isn't it? Because we're on. So that is an indication that that's because the bias is a little bit higher than it should be. So it's drawn that voltage down slightly. Right, let's see what we've got plate to cathode then, shall we? Because we need that to measure the bias. 320.8, we'll call that 321. So let's just do another check now. 321. About 23 volts. We'll just do a rough 23 divided by 200 divided by 2. So those tubes are drawing 57.5 milliamps each, including the screens. So we'll take 5% off for the screens, and then we'll times that by 321. So the tubes are running at 17.53, 17.5 watts. And yeah, I would imagine this had 6L6, those 6L6Gs are about 19 watts. It's very noisy though, and not much output. So yeah, it's very sick, this amp. It is running off the current limiter though, and the only reason I've took it off really is because this node 1 cap's been replaced. Here on the where I'm measuring the voltage with a meter upstairs, that's straight off the 5V4. I'm getting 350 volts, but it's jumping around a little bit. 580 milliamps, so about 530 milliamps this is drawing. So there we go. It's running sick. We don't know whether any of those tubes are blown, do we, or what's going on there. The wiring on there, it looks a bit suspect. So yes, it's so I think we'll power down now. We've got most of the information we need. Just need to measure that bias resistor there, which is also tagged onto the tube socket. Dearie me. Oh. $198, so near enough. Right, so we've got the RCA manual here, and we're just looking at this 5V4, and just get something to point with. If we look here, total effective plate supply impedance per plate is 100. Now when I measured across those plates, we got 93.3 ohms. The maximum filter capacitance is 10 microfarad, and we've got 16 on here. It's been pushed a little bit more, which is fine, but we can't really push that anymore. There is, obviously we're not going to be using this transformer, so that may not be an issue anyway. Depending on what the resistance winding is going to be on the other transformer, resistance of the winding. There is other ways of doing it. We can put resistors in series with the wires from the secondary to the anodes to boost up the resistance, which will then allow us to increase this capacitor to about 32 microfarad, because there's quite a background hum on this amp, which I can hear even as quiet as this is. So, but that's all really to do with the newer transformer, and that's something I'll have to discuss with Michael, because we need to get the specs right for this. We could, however, go to a GZ34 on there, and that would also give us more plate volts, and is a much more efficient tube. In fact, I think I've got one of those kicking around somewhere. Well, not kicking around, but it's just a figure of speech. It wouldn't be much good if I was kicking it around, would it? So let's just have a bit of a recap then on what this amp needs. It doesn't need a power transformer from a perspective of it's damaged or anything, although it was a bit noisy when we first plugged that in, and then it seemed to clear. But we're changing the transformer anyway. It's just convenient for the UK because we're on 240 volts. The ground needs to be put on the chassis but obviously we'll be changing the power cord anyway. And we need to change all the grounding on here. Any grounding that is down onto these riveted tube sockets, that's all got to be changed. Can't leave that. These rivets relax, then this amp will have all sorts of problems. We're going to mod these, the sockets, the sockets, the channels. We're going to put a master volume in it. We've got to change all these sockets on the back, and look at all this impedance thing that's going on here. It's really not good. And obviously the input sockets are just, well, are shocking. So we've got to sort all that out as well. So a fair bit to do. That's just off the top of my head. We've also got to look at these output tube sockets. These output tubes, because obviously they are GCs and not G's. Right, now I've got a pair of these tubes. These are 7591s, and these would go rather nice with this amp instead of those 606 GCs. They have a dissipation of 19 watts, and this amp's biased at about 17 It's just over 17 watts. They would be excellent for this amp. And you can see the limiting values are 19 watts and maximum of 550 volts limiting values. They're 440 for the screen. We're not going to be near that. We're only going to be just over these values here, 300 volts. So that's an option as well for this amp. That's another option. Would certainly be better than those GCs. They're way too big for this amp. We'd have to rewire the two bases, of course, but that's no big deal. In fact, we've got the pin out here. If we look, so pin 1 is as normal, not connected. Pin 2 is filament. Pin 3 is anode. Pin 4 is grid 2. That's the same. Pin 5 is the grid on a 6L6, but on here it's the cathode. So we need to disconnect pin 5 on the 2 base of this amp and move it to pin 6. And then we disconnect the cathodes from pin 8 and put it to pin 5, connect it to pin 5, and that's it. 7 is the filament again. So yeah, not too difficult to do that. I think if this was mine, I'd go for the GZ34. Then we could increase this capacitance on here, because that's noisy and all the deal. We're not that's the node 1 capacitor. So we need to, I think the way to approach this, and of course, is this can here, is to remove this can, because it's been in there years, and put in a 32, something like that, and then use 132 for node 1 and the other one for the screens, the orange wire there, you can see me pointing at it. And then the preamp capacitors, I think it would be best then to mount those in here securely and do away with this altogether. Just don't like the idea of that. There's some serious safety issues in this amp. That ground is one of them. And again, if this is grounded, well, that's actually grounded down to this array of wires there, which is then grounded around the transformer bolt using a tag. So don't like that. This here, what they've got there, the neutral, the negative, whatever you want to call it, I always call it negative, neutral, that's no good. That just needs addressing. But we're going to put a switch on this amp, a power switch, and disconnect the power from the tone control, so that could go on the back. And obviously we could secure this better by simply having a double pole single throw switch, which is what it really should have. And that presents some more problems as well, because speaker sockets are here, which kind of takes away space for the power switch. We could put the power switch on the front, but we'd have to drill through this panel here. And if we just pull back, as I just take that off, and if we just pull back there, you can see that we'd end up coming straight through the logo on the front panel. So there we go, that's the assessment done of the Masco ME27. A few options there. Let me know what you think in the comments. This video's probably got a bit long, and we didn't get no guitar through it, did we? And that's probably because, well, we don't think we would have done. It's a badly foul, as we say up my way. It's a badly foul. So that'll do it for this one. So thanks for watching. You all take care, and I'll see you all in another video. Bye bye for now.